Okay, so here's the last section, everybody's favorite word problems. So let's get into this. I'm going to do 3 out of the 4 examples. I can do the 4th one in class, just so that I don't make this more than 20 minutes long. Essentially what you're going to do for something like this is we need to deal with maximum and minimum. Often, if you're going to deal with engineering or something like that, you'll encounter problems that involve max or min. So what that refers to is, so if you have a positive x squared value, you're going to have a parabola that looks like this, and down here at the bottom, this is going to be a minimum value, as opposed to if I do the opposite, there's a value at the top here, this is the max. So the maximum or the minimum is going to be at the point where I'm at the vertex in either case. So that's what we need to look at, is maximizing and minimizing some sort of value. So looking at the first example here, we're told that 2 numbers have a difference of 10, difference meaning subtraction, and their product is a minimum. Product meaning multiplying them together. And we want to know what those 2 numbers are. So to start this off, we need to look at what are the 2 equations I'm going to deal with. So first of all, I've got 2 numbers that have a difference of 10. So it doesn't matter what we call these 2 numbers, we can pick whatever we like. So let's just pick A and B. So A minus B equals 10. There's the first equation. And then we've got that their product is a minimum. So we're told that A times B is going to equal a minimum. This is where my vertex is going to be, at that minimum point. So in order to solve this, what I'm going to do is I'm going to solve this for one of the variables and substitute it in here. And I'm going to solve for the vertex, and that's going to tell me what I need to know. So let's rearrange this equation. So let's switch this and say that A equals 10 plus B, or B plus 10, doesn't really matter. Like this, and substitute it in here. So instead of A, we've got 10 plus B times B is a minimum. So let's expand that one out. We get B squared plus 10B is our minimum value. So we need to solve this, or try and get it to a value that's going to help us. So we need to determine what the perfect square of this is. So in order to figure out the perfect square, we're going to split this equation. We're going to have divide this by 2. So we'll get B squared. We're intending in this to get B plus 5 squared. That's what I want to do. Again, just dividing this by 2, we get this. So we'll have this minimum value is B squared plus 10B plus 25, and then we also need to subtract 25 from this. Again, here's our point where we're splitting this equation in half. So my perfect square is B plus 5 squared minus 25. And this is going to be, if we're looking at the minimum value, this is my point. So my vertex is at the point of -5, -25. So notice, this is going to be the lowest value that we've got, -25, and this is my B value. So this is the B, this is the minimum value. So I've got the B, now I need to figure out what A is. So in order to do that, I need to take this B value and plug it back into my equation. Well, any equation, doesn't matter. Well, actually it does, because I do know what the minimum is. So I could plug in B and the minimum and figure out what A is, or just use this equation here. So I'm just going to use that one. So I've got A minus B equals 10. So A minus -5 equals 10, which tells me that A plus 5 is 10. So subtract 5, A is going to give me 5. So there's my 2 values. A equals 5, B equals -5. So there are my 2 numbers. Sometimes this question will ask you what is the minimum value that they could get, so then you'd have to give me this, or it could just be give me the two x and y values. Let's try a different one here. So this one is going to deal with a rectangle. You'll find that the three equations, or the three things that I'm going to do, are the basic three types of equations you'll get. Looking for, talking about two numbers, talking about a fence, or a yard, or a backyard, or whatever, and you have a certain amount of material that you want to make a fence out of, or money, dealing with profit. These are the three main kind of equations. So here we've got a rectangle lot is bounded on one side by a river and on the other three sides by a total of 80 meters of fencing. We want to know the dimensions for the largest possible area. Largest, maximum. You should automatically be thinking that. So let's draw this out so that you can understand what this looks like. So here's my river, and we're told that I've got some lot that's on here, and this river's on this side, and this amount of fencing is 80 meters. So what we've got is let's call this length, and these two sides are widths. Could have switched that, doesn't really matter. But from this, I can make two equations. I know that 2 times W plus L, so the length of these sides, is equal to 80, because we're told that equals 80 meters of fencing. And we know that my length times my width is going to equal a max. So those are the two types of equations we're going to deal with. The method for solving this is going to be the exact same. Solve for one of the variables here, plug it into this equation, and then solve. So since L is all by itself, it's easier to solve for that. L is going to equal 80 minus 2 times W. Substitute, and let's solve. So we've got 80 minus 2W times W is going to be our max. I'm just going to leave that side out for now. And so multiplying this together, we get negative 2W plus 80W. And here I want to complete the square with this. This is, we can just call this our area, max, doesn't really matter. This is what I'm looking for. So I want to complete the squares for this. So you can imagine here I've got a plus 0, if that helps you. And then let's solve for this. So first I factor out the negative 2. Sorry, this should be W squared. So I've got W squared minus 40W. Again, plus 0. And I want to figure out what is the perfect square of this. So I want to divide this by 2. So I should be getting W minus 20 squared is what I'm looking for. So I'll end up with minus 2 W squared minus 40W plus 400. And then I've got the plus 0, and I also need to deal with this. So when I multiply these two together, negative 2 times 400 will give me negative 800. So I'm essentially subtracting 800 from this side, so I need to add 800 onto the other side. Sorry, you can't see that. Like such. So I get negative 2 times W minus 20 all squared plus 800. So what does this tell us? Well, my vertex is at the point 20, 800. So the 20 here, that's my width value. And the 800 here, this is the maximum value. So this is my max area. So this means if my width is 20 meters, I can get this max area. So I already know what the width is. It's 20. So looking back at my diagram, so this is 20, this is 20. Using this other equation for L, I can solve for what is the length. So rearranging this, we get, or not rearranging, substituting, L equals 80 minus 2 times W, which we figured out is 20. So 80 minus 2 times 20 gives me 40. So my length is 40, my width is 20. So these are the dimensions. It's 20 by 40. You can put meters in here. I'm not going to be picky about the units, but that is that. So there's my answer. Length 40, width 20. Let's move on to the next one. So this one is a cost slash profit. So we're looking at, we've got an app being marketed to people at a starting price of $20. It says that 300 people would buy the app at that price. It says if we do some market research, we figured that for every time we increase this price by 5, we're going to have 30 people not willing to buy that, 30 people less. So we want to know, what price should I set that app to be so that I'll have a maximum profit? So this one, there's kind of 3 equations, but I'm going to show you this in one. So the easiest way to explain this is just to think about what would be my profit, or how would I figure out the profit for something like this? So profit is going to equal the price of the app times the number of people. So this is the equation that we're going to get. This is a times on x. So for your profit equations, you're just going to start with this. So for our beginning case, we're told the price is 20 and the number of people is 300. So I'm going to start with that just at first. But I'm going to change something a little bit here. So what are we going to do to change the price in this equation? Well, we're told that as we increase by $5, we're going to decrease the number of people by 30. So for every increase in this price by 5, so increase 5 times whatever, let's just pick a variable a. So every time I increase by 5, I'm going to lose 30 people. So this is what I'm saying. Every increment I increase by 5, my price, I'm going to lose 30 people who are going to buy it. So this is the equation that we're going to use. So there wasn't 2 equations like the other ones. It's just one simple one like this. But it's going to be easy because the profit is always price times the number of people. And then you're going to increase or decrease it as you do here. So let's multiply this out. I've got my calculator here to help me out for this because I can't do all this in my head. So 20 times 300 will give us 6,000. 20 times negative 30a, so minus 30 times 20 gives us negative 600a. 5 times 300 will give us plus 1500a, and then positive 5 times negative 30 will give us minus 150a squared. Rearrange this equation and combine like terms. We'll get minus 150a squared plus 900a plus 6,000. So this is the equation that we've got, and we want to figure out what is the profit max, which again is just what is the value at the vertex. So once we solve for a, we'll be good to go. So in order to do this, first things first, we're going to split this equation here, 2/3. I've got a number in front of a squared, so let's factor that out first. So negative 150. What I've got left inside is a squared. Take 900 divided by negative 150. I think that's 6, but let me just double check. 900 divided by negative 150. Yep, will give you 6 in here. So I divided by negative, so this positive 900 now becomes negative. Sorry, there should be an A there. And then we've still got plus the 6,000. So we want a perfect square here. The perfect square that I am wanting is going to be A minus 3 all squared. That's what I'm looking for. So minus 150, A squared minus 6A plus 9 if I were to actually do that square. And then I've got plus 6,000 over here. And I need to adapt to what I just did in the equation here. So negative 150 times 9. Negative 150. Well, essentially what I'm doing is I'm subtracting 1350 from this side of the equation. So therefore I need to add that same amount to the other side. Simplify this down. Negative 150 times A minus 3 all squared plus 7,350. So there's my equation. My vertex is at 3,750. So this is the increment, and this is my max. So careful with the word problem. You need to actually figure out what it's asking for in the question. So in this one it says, at what price could the app be sold for the product to be a maximum? Remember, my price here was 20 plus 5 times A. So in order to solve this, I need to go price equals 20 plus 5A to get us the max. That would, the A value for that is 3. This is the A value. So my price is 2 plus 5 times 3. Sorry, that should be 20. So 20 plus 5 times 3. 5 times 3 is 15. So add that to this. $35. So that's how you solve these word problems. You'll have some quadratic equation. You're solving for the maximum or the minimum value, and making sure at the end you're giving the exact number that you want for this.